Hello everyone. In this video, we are going to cover searching. See, searching is an algorithm which is used to check whether any given element is present in a data structure or not. Searching can be done in many ways. Some of them are linear search, binary search, jump search, and linear search and binary search are the most famous ones. So we are going to cover both of them in this video. In linear search, we sequentially compare all the elements of the array with the given key. In the given image, we have a key 20 and we need to compare linearly with all the elements of the array until we get the correct match. So, we start from the beginning and we linearly traverse the array until we get the correct match. After reaching the index 6, we found a correct match. So, we get our answer. In this question, we are given an array of size n and an key. We need to find the first occurrence of key k and return the position of the key in the given array. If the key is not found in the array, then we have to return -1. So now let's program linear search. The link of the problem will be given in description box so you can also try it. So according to question, if we take this example of an array and we assume key to be 12, the index of the key is 3 in the given example. So we do not have to return the index of the given key. We have to return the position. So what will be the position of 12? It will be 1, 2, 3, 4. That means index plus 1. So if we find any key in our array, so we have to return index plus 1. And if we do not find our key in the array, for example, if we try to search 15, it is not in the array. So in this case, we have to return -1. Coming back to the question, for doing linear search, we will have to write a for loop from I equal 0 because indexing in C++ starts from 0 till I less than n, or you can write I less than equal n minus 1 and then we will increment I. Inside for loop, we will write the condition and check if ith position, if ith index of array contains key. If this condition satisfies, it means we have found our key. So we will have to return the position. Focus, the position here is I plus 1. I is the index whereas I plus 1 is the position. And if we do not find our key in the array, we will have to return -1. So what will be the time and space complexity of the given program? Here we are writing a for loop from I equals 0 to I less than n. This means we are using big of n time complexity and we are not using any extra space, so space complexity will be big of 1. Coming to binary search, this searching algorithm requires an array to be in sorted order. In the given image, we can see our array is given to us which is in increasing fashion and we are also given a key. We have to find a key in the given array using binary search algorithm. This algorithm requires us to use two variables. The first one is low, which will point to the 0th index of the array, and another variable is high. This will point to the last index of the array. These both variables, low and high, signifies the search space. This means our key will always lie between low and high if it is present in the array. So the next step in this algorithm is to calculate mid index, and the formula for calculating mid index is low plus high divided by 2. In this case, low is 0 and high is 9. So the mid index will be 4 because 0 plus 9 is 9, and if we will divide it by 2, it will be 4. It is floor division. Now we will compare our mid index element with the key. As we can see, key is greater than mid index. What we will do in this case? See, After applying logic, we can see the left side of the array will always contain the elements which are less than 16, and the elements which are greater than 16 always lie on the right side of mid index. So we see our key is greater than mid index. So we know it will always lie on the right side of the array. So we reduce our search space by changing the value of low, which is 0, to low equal 5, which will be mid plus 1. After changing low variable from 0 to 5, we reduced our search space, which was 0 to 9, and now it is 5 to 9. Now we will again calculate mid index. Now we will again apply the formula low plus high divided by 2. Here in this case low is 5 and high is 9. If we add them both, the answer will be 14, and if we will divide this by 2, the answer will come 7. So the mid index will be 7. Now we will again compare the mid index with the key. Now in this case the key is less than the mid index element. So what we will do now? We know if the key is smaller than the middle index, the answer will always lie on the left side of the mid index. So we will reduce our search space by changing the value of I from 9 to 6, which is mid minus 1. So the new values of low and high are 5 and 6. Now again we will calculate the mid index, which will be in this case 5, because 5 plus 6 divided by 2 is 5. So now we will check if the mid index element is equal to key. So now we will see the mid index element is 23 and our key was also 23. So we have got our match and we will return our answer as 5. Let us take another example. In this case, the element which we will be searching will not be present in the array. For example, this is the array which contains 1, 3, 5, 9 and 15, and we have to search for 7. As you can see, 7 is not in the array. So what was the step for binary search? We will initialize 0th index with low and last index of the array with high. So here lower bound is same as low and upper bound is same as high. So here we will be initializing low with 0 and high with 4, as 0 is the first element of the array and 4 is the last index of the array. Now we will calculate the midpoint. So what was the formula for calculating midpoint? High plus low divided by 2. Here 0 plus 4 divided by 2, which will come out to be 2. So this is the midpoint. Now what was the next step? We had to compare our key with the midpoint element. So our midpoint element is 5, and what were we searching for? We were searching for 7. So 5 is less than 7. So where should our answer lie? Our answer should lie on the right side of the mid index. So what we will do? We will update our low from 0 to high plus 1, which will be 3. In next step, we will be having low as 3 and high as 4. Now we will apply the formula to calculate midpoint. Here 4 plus 3 divided by 2 will come out to be 3. So now we will compare this element with the key we need to search for. The key was 7 and the mid element is 9. So 7 should always lie on the left side of the mid element. So what we will do? We will update our high to mid minus 1, which will be from 4 to 2. So now we see the low variable is higher than high variable. It means our search space has grown in negative. Our low is greater and high is smaller, which is not possible. So What does it signifies? This signifies that our element is not found in the array. So we will return -1. Now let's program binary search algorithm. Firstly, we will initialize low and high variable. Low will be 0, which is the starting point of the array, and high will be n-1, because the high variable is the last index of the array, and the last index of the array is always the size of the array -1. Then we will write a while loop, and the condition will be low is less than equal high. As we saw in the last example, if low exceeds high, in this case the element is not present in the array. But here we have wrote low is less than high. This means the element may be present in the array. So inside it we will calculate mid. The formula for calculating mid was low plus high divided by 2. Now we will write a condition if the mid index element is equal key. Then we will return the mid index, and if mid element is less than key, in this case we have to reduce our search space. If the mid element is less than key, this means our key lies on the right side of the mid index. So we will update low to mid plus 1, and the remaining cases mid element is more than key. In this case we will update our high to mid -1. If the element is present in the array, the program will terminate from here, and if the element is not present in the array, the control will come out of the while loop. And as is written in the question, if the element is not found in the array, we have to return -1. So outside while loop we will return -1, and this will only run if element is not found in the array. Now let's check for its proper working. So the program runs fine. Now let's talk about time and space complexity of the given program. The time complexity of the given program is log n. Because the array is continuously getting divided into half, this time complexity of log n can be proven by using Master's equation, which you can refer through Geeks for Geeks or any book. Now the space complexity of the given program is big of 1, because we are not using any extra space for our solution.